good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today I'm sleepy because I have a cold. But the show still must go on, and we still must do math every day. Do math. Honestly, the more math you do with knowing what the correct answer is, the better you will become at math. I do about 12 hours of math every day, so hence I'm a lot better than some people at math. So this is a chapter 4 review submitted by one of the students in a nearby district from where I live. And this is chapter 4 review. So this is a chapter 4 review that is linked with Big Ideas, the Algebra 2 book for chapter 4. We're going to do this in 2 videos because the review sheet has 2 pages. So the first page is all going to be about adding, subtracting, multiplying, and dividing with polynomials. And then the second page is going to be about graphing and factoring them, okay? So if you're here for adding, subtracting, multiplying, and dividing polynomials, you are in the right place. Congratulations. And without further ado, let's get started. So some of these particular functions, these polynomial, I guess not functions, expressions, are a little bit easy to confuse because they're in the straight line. And normally brains don't think in this fully linear pattern. It's easier to see things in this like up-down fashion versus in a very long line. So one of the recommendations that I usually give my students is that you should not put it like that. You should in fact stack it one on top of the other. And as you're writing, you're actually going to say, okay, well, if I'm going to add all of these, I'm just going to add this whole entire bottom row to the top row. And I also want to make sure that I link up these like terms, right? So for example, I have x to the third, 7x squared, and then minus 2 would actually not show up here. It would show up here. And that makes my life easier when I'm writing it on a piece of paper, when I'm putting one thing on top of the other. And so I'm capable of really seeing what I need to add. So now I'm here at 3x squared because we have to remember the invisible 1, so plus 8x squared minus 3x plus 2. Final answer, that's it, we're all done. So now all of the problems are going to be this basic, but there are some that usually are basic in the beginning of the chapter. So one of the things I want to mention is this minus is the real killer of answers. In fact, most students either forget or don't remember or just overlook that this negative is actually a -1 that needs to be distributed to every single term inside of these parentheses. So one thing that I would recommend is I would say put -3x, whoops, not squared. Did not mean to do that, to the third. And then as you move forward, you're going to still continue to place the like terms one on top of the other, and you're going to make them all the opposite sign. So if it's positive, make it negative. If it's negative, make it positive, right? So we're going to subtract 5x squared, add x, subtract 8. You can also go in and do this like rainbow method. There are lots of things that you can do, but realistically speaking, I think this is one that I found that most students tend to appreciate. All right, so 5 minus 3 is 2x to the third minus 9x squared minus 2x minus 7. Okay, that looks about right. So, and that's it. That's your final answer. Again, we don't care what x is. We just want to combine like terms, right? So we're back in that kind of like early pre-algebra sense, just kind of on steroids, right? Because there's a lot more going on here. Okay. The next thing that we're going to do is we're going to multiply. So that was one adding problem, one subtracting problem. They're all roughly the same, so I don't think we need to go through any more. There aren't any more on the handout either. Okay. So then we have these guys. So one of the things that I love about distributive property is when I teach distributive property to middle school students, I give them 2 options. I give them the option of the rainbow method and the option of the box method. There are tons more other options out there. I know of at least 2 more, but those are the 2 main ones that I've seen teachers use on a frequent basis. The rainbow method, I hate. I hate the rainbow method because when you get to this place, the rainbow method is way more confusing. And it is not the best method for these problems. The box method, on the other hand, or the area model, is my favorite method because once again, when you see things stacked up, it just makes your brain feel at ease. It just makes it make more sense. So the area model is basically where we take one thing and we multiply it by another, okay? And since I have 3 terms by 2 terms, I'm gonna make a 3 by 2 box. You can make it a 3 by 2 or a 2 by 3, and honestly, whatever makes you happy, it doesn't really matter, okay? You will get the same exact answer in both cases. So I'm gonna label all of my numbers. Please do not forget your negative signs. And then I'm gonna label this here. I have seen some students just write +5, like as it's written, that's how they write it in. So that's another thing that you can do. And then we're just gonna multiply piece by piece, right? So 2x squared is gonna be 2x to the third. Then I'm gonna have negative 3x squared. Then I'm gonna have positive 5x. Now I'm gonna double it and make the negative sign. So negative 4x squared, positive 6x, and negative 10. One of the things that I definitely want you to notice is when I have these guys here, oh, whoops, I need a different color. Okay, so these guys here are the same type of terms, and these guys here are also the same type of terms. So that's something that as you move through, you'll notice these patterns that these guys are the same and these guys are the same. And so you're just going to go ahead and combine those two. And we knew that something would be the same, right? Just because FOIL, we've done that before, right? But when we have 3 terms more than that, it gets a little bit too intense, right? So I'm going to end up with 2x to the third minus 7x squared plus 11x minus 10, final answer. Now, sometimes I'm going to have three different sets of parentheses that I'm going to need to multiply. Now, one thing that you can do is you can go in and you can say, okay, I have these 2. I'm going to use the rainbow method for that. I'm going to FOIL those. That's a little bit basic, right? X squared minus 2x plus 4x minus 8. Combine like terms. X squared plus 2x minus 8. Call it good. But we cannot forget this guy. This guy is still here. We still need to multiply by him as well. And so we're back in this same situation where we have 3 terms in one, 2 terms in the other. FOIL is just going to be too much. Well, you can't even use FOIL. It's just multiple distribution. It's not as easy. So I'm going to make a 2 by 3 box in this case. Again, it really doesn't matter how you end up like lining them up, right? You can do 2 by 3, 3 by 2, whatever, so long as you have the right amount of boxes, right? So negative 3x, positive 3x, negative 1, and then x squared plus 2x minus 8. Actually, if you want to pause the video, do this math on your own in a separate and like in a different way. Instead of doing 2 by 3, you could do 3 by 2. And then unpause the video, you'll see that even within the same rectangle, you're still going to have the same exact terms. And when you add them all up, obviously they'll be the same exact terms. The only difference that I can imagine is if you forgot a negative, or if you did like 2 times 1 is 3, you know, something like that. That would be the only issue. Okay, so I'm going to multiply these guys out, and then I'm going to end up with 6x squared here, negative 2x. This is going to be a positive 8, and this is going to be a negative 24x. Beautiful. So now we have these guys, and these guys are my like terms. You actually don't have to point out that they're like terms when you're showing your work. You can just, combine them. That's totally fine. I'm a big fan of like visual things, so I do want to bring attention to, hey, these are the same, these are the same. I'm going to go ahead and combine them. All right, so then I have 3x to the third plus 5x squared minus 26x plus 8. And that's it. That's my final answer. Now, one of the things that I do want to mention is if you feel like I'm moving too fast, you can always put me in slow-mo or rewind, watch it again, try it on your own, see what happens, and then go back and compare where our differences are. Okay, so these two are actually special cases of multiple distribution or FOIL. This is actually a very typical Algebra 1 problem. So this, I would say, is more of a review question than an actual test question for an Algebra 2 perspective. For Algebra 1 is totally fair game, but I think it's a little bit basic for Algebra 2. So I'm going to just add in a y in here. And that makes it a little bit more Algebra 2. You can also put in like a 17, and that would make it more of Algebra 2 material, okay? So if I remember correctly, 17 squared is 289. So this is the difference of two squares. Once you see that the same terms are in each parentheses, and there is one of them with a negative and one of them with a positive, then you should know that it is the difference of two squares. The difference of two squares. And in its most basic form, the difference of two squares is some term plus another term times some term minus another term. And then when we FOIL this out or multiply this out, we end up with this a squared minus b squared scenario. So if I were to solve this without really showing much work, like none of this would be in my answer sheet, right? If I would have this assessment and I would look at this problem, I'd be like, okay, 17x, 3y, 3y plus minus. Okay, well, I know my answer is going to be 289x squared because I've squared the first term, minus 9y squared because I've squared the second term. I would double check my math on that because I am a little sick, so I might not get the right number or I might have switched something around. But that looks kind of correct to me. So this is just a very typical thing. Your numbers could be very different, obviously, but the more challenging types of numbers are going to show up in Algebra 2. The more basic ones will show up in Algebra 1. This is another type of like a difference of two squares, like a special case, we could call it. This is a perfect square trinomial. So it is so perfect. It is a perfect square trinomial. So what this is saying is that if I have a plus b squared, I'm going to end up with an a squared and a b squared at the end. And in the center, I'm going to have double AB. This is one of those types of perfect, like special cases that you're supposed to have memorized as an Algebra 1 student so that you can apply it to something more challenging as an Algebra 2 student. Again, I don't think that something this basic is going to show up on an Algebra 2 test. This is total fair game for Algebra 1, but I think it's more of a review question for Algebra 1 students, for a review question for Algebra 2 students. I think you might end up with something a little bit more challenging like 12x plus 9y, or maybe WZ or something along those lines, adding in additional variables, things of that nature. The process is still the same, right? The other thing that I do want to mention is if you have an a minus b scenario that's squared, that's going to look a little bit different. You're still going to have the a squared, you're still going to have the plus b squared, but in this case, you're going to have minus 2ab. Okay, so in this case, we have a plus. Let's say we do make it 12 and 9y. So 12x is going to be 144x squared. 9y is going to be 81y squared. And then I'm going to multiply the 12 and the 9. I'm just going to do some quick maths here. 90 and 18 is 108. And then double that. So if I multiply that by 2, I'm going to get 216. So I'm going to add 216. Notice how it says AB, right? So I'm taking the whole A term and the whole B term. So not only am I going to do 12 times 9, but I'm also going to do 12 times 9 times x times y, right? So that's where my final answer would be. This is totally typical of Algebra 2. I've seen gross numbers like this before. I don't know that I would see very many fractions on the Algebra 2 level for this particular section, okay? But these numbers, these larger numbers, are total fair game. So now what we're going to do is we are going to divide. And before we talk about division, is you're going to learn two types of division in Algebra 2. You're going to learn a regular long division and a synthetic division. And I'm going to do on each of the last two slides, I'm going to do one long division and one synthetic division just so that you can see the difference. And I'm pretty sure I'm going to guess you're going to like synthetic division more than you like long division. Long division is something that's going to bring you back way back to elementary school when you first learned how to do long division. One of the things that I do want to make sure that regardless of which method you prefer and regardless of which method you use, you are going to need to make sure that you have every single term in your dividend divisor. Now I can't even think anymore. Words are hard, guys. The number that you're dividing, you want to make sure that you have this x squared in here. And in order for x squared to show up, but not really show up, right, because it's not there, we want to make sure that we have like this placeholder. So we're going to make it this 0x squared in here, because I want to have to the third, to the second, to the first, and then technically this is like x to the 0 power, right? The same thing is going to happen here. Because I have 5, 4, 3 is missing, I'm going to add in 0x to the third in here, and then I'm going to go 2, 1, and then nothing, right? So the way I'm going to set up my long division is going to be x to the third plus 0x squared minus 3x plus 10, and all of that is going to be divided by x minus 1. Now, when I look at this x minus 1, my job is to make sure I'm determining how many of these x's are going to fit in this x to the third power. So I know that x, like 3 x's are going to fit into x to the third. So I'm going to say I need 2 more x's, right? So if I take x squared times x, I get x to the third, right? And then I'm going to take this x squared and multiply it by -1. So I'm going to end up with -1x squared. And this is why I need that placeholder, because if I didn't have the placeholder, right, I would have had this -3x here, and this would have been underneath, and they're not like terms. So just like in the very first two problems, when we had those like terms stacked one on top of the other, we want to stack like terms here one on top of the other, okay? And the other thing we remember in long division, we actually subtracted, right? So when we subtract, we're going to subtract the whole entire set of parentheses, not just the very first term. So technically I'm doing x to the third minus x to the third, which basically just cancels out. And then I'm doing 0x squared minus negative x squared. So really I'm adding, because a minus negative is going to be a plus, right? So I'm going to end up here with x squared. I'm going to bring down negative 3x. And then I'm going to go in with the next set. How many times does x fit into x squared? Well, I just need one more x, right? So I'm going to do plus x. And I'm going to take this x and I'm going to multiply it by x and negative 1. So that's going to be negative x squared minus 1x, right? So I'm doing the same thing that I did before, kind of in that regular long division style. But because I have two terms that I'm multiplying by, I'm going to go in and I'm going to do the same thing again twice, right? I'm still going to subtract just like I normally would in long division. I know that x squared minus x squared, that'll cancel. And then I have negative 3x minus negative 1. So that's really negative 3 plus 1. So that should be negative 2x. Then I'm going to go ahead and I'm going to bring this plus 10 down. And now I'm going to go with my last set. I'm going to go, okay, how many times does x fit into this negative 2x? Well, x goes into x one time, so I don't really need another x. And then x, like there's this invisible 1. So 1 times negative 2 is going to give me negative 2. So I'm taking negative 2, multiplying it by this 1x to get this negative 2x. That's going to give me the ability to eliminate later when I subtract everything, okay? And then I can't forget about this negative 2 times negative 1, which is going to be positive 2, right? Because negative and negative combined give us positive. And then I'm going to subtract the whole thing. Well, negative 2 minus negative 2 cancels. And then I have 10 minus 2, which is 8. There is nothing that I can multiply by x to get me 8, because I don't know what x is, right? So this 8 is kind of like that remainder that we used to have way back when in elementary school. I know usually most middle school teachers kind of say, okay, remainders are gone. We are now using decimals. So in this particular case, 1x times nothing gives me 8. So I'm going to have remainder 8. But instead of writing actual remainder 8, I'm going to go in and I'm going to write plus 8 over x minus 1. And if you remember, when you do a remainder, so let's say, for example, I have 9 divided by 2. I know 2 goes into 9 4 times, right? So I'm going to subtract 8, and I'm going to be left with 1. Option 1 is I can just go remainder 1, but usually we kind of stay away from the remainder 1 when we are in anywhere above elementary school. Instead, we're going to take this 1 and we're going to say, really, we have 1 out of the 2 that we are dividing by. And we all know that 4.5 times 2 is 9. So my answer in this case would be 4.5. So this is kind of like that same logic. We're going to take our remainder, that 8, and put it over what we are dividing by in order to get the final answer. So my final answer would be this. In this case, we don't do a plus, but here we do. Please make sure that we are adding this. We are adding this remainder in so that we can actually see that it's not quite a fully divisible expression, okay? That's the goal. We want to make sure that we let them know it's not a fully divisible expression. Okay, so this is my long division process. Now, my long division process is long, that's why it's called long division, right? Then we have something called synthetic division. Now, generally speaking, when we're looking at something synthetic, we're looking at something that's made possibly a little bit faster, right? That's a little bit more easier to make, right? Or a little bit easier to do and whatnot. So let's talk about synthetic division. I like to call synthetic division upside down division because we take the bar and we just, oh my goodness, do the same thing. Sometimes I've seen long division done like that with a line going through. Honestly, it doesn't matter. Do whatever makes you happy. I've seen it as upside down birthday cake, kind of like that. Normally, when I teach the greatest common factor, least common multiple types of problems, I end up saying that this is an upside down birthday cake, because then we end up with things going like this. And it kind of does look like this upside down cake with multiple layers, and just we're seeing one portion of it. Okay, so we said that we needed to have a placeholder. When we have these placeholders in synthetic division, we only take a look at just the like the coefficients of every single one of my terms. So my x's don't show up in my long division. Okay, so if I only am looking at my coefficients, I'm going to have 4, 2, 0, right? Because I have that 0 as a placeholder, -3, +8, -1. Now, let's talk about the number that we're dividing by. So in this particular case, I have x plus 2 in my parentheses. Now, this is one of the reasons why I love Algebra 2 so much. I feel like it's such a big topic. It's such a big deal conversation piece. It is phenomenal. It is right when everything kind of like converges together and you're like, oh my gosh, brain exploding, Illuminati confirmed, all the things, right? Like, this is it. In the past, when we would look at x plus 2, we would have seen it in something that we factored, right? And so when we factor things, we end up with 2 sets of parentheses that equal to 0. When each of these parentheses would equal 0, i.e. x plus 2 equals 0, x would no longer be linked with a +2, x would actually equal -2. So this is why we're dividing by that -2. Now, I can talk about why Algebra 2 is way more fun in another time, but for the moment, I want you to understand that we are basically setting this equal to 0 so that you can get your zeros, right? Okay, so for synthetic division, we are going to bring down my first term, 4, and then we are going to multiply that by the number that I am dividing by. So 4 times -2 is -8. Then I'm going to add or subtract these two. So 2 minus 8 is -6. Multiply that by -2, get 12. 0 plus 12 is 12. Multiply that by -2, get -24. -24, and then -3 give me -27. -27 times 2 is +54. 54 plus 8. I feel like I did something wrong, but it does not look like it. I'm checking my math real quick. It seems like things are correct. 4 times 2 is -8, -6. 12 and 2 is -24. Yeah, okay. 54, this is going to be 62, and then this is going to be -124, which will give me a remainder of 125. This is kind of a gross thing, but can you imagine doing long division with all of this jazz? I'm not quite sure why some of this stuff was erased. Oh well, that looks a little funky to me. So how do we get this whole denominator, or this whole bottom piece, to look like that? All right, so first things first, notice how when we, actually this is going to bother me a lot because I need to go back to this. So give me 1 second. Holy guacamole, this we canceled out. This became negative x squared, and then we subtracted 3x, and then we did this, and then, oh my goodness gracious, that was so wild. Okay, so I want you to notice one of the things. The first thing that I want you to notice is in this particular case right here, when we divided x to the third by regular x, we ended up with our exponent being 1 lower. So if I'm going to take x to the fifth and divide it by x, essentially my first term in my quotient is going to be x. Whoops, just kidding. Just kidding, incorrect colors. My first term is going to be 4x to the fourth. And as you notice, in here I have second power, first power. Technically, this is the 0 power, and then the remainder. I'm going to do the same exact thing. I'm going to go 4, 3, 2, 1, nothing, and then remainder. So my terms that are going to have this x to the fourth, x to the third, x to the whatever are all of these terms. And then this will be my remainder. So let's see how that looks. Minus 6x to the third plus 12x squared minus 27x plus 62x to the 0 or nothing plus this negative 125 over what we are dividing by, x plus 2. Again, this is a really gross problem. You'll see as you move on through chapter 4, your answers will not be this gross. In fact, most times for your initial learning of the topic, you will not have any remainders because we actually don't want remainders. We want to be able to graph it. This synthetic division is going to help us. It's going to help us really find the zeros where we want to graph the entire function. Okay, so my recommendation is to have watched the last 2 problems being completed, attempt these 2 problems, see what you can do in here on your own, and then come back and check in with me, right? So then you can compare what you did differently than me. Okay. I'm going to start with this one as a, actually, no, I'm going to start with number 9. So we're going to put in negative x to the fourth plus 2x to the third minus x squared plus x minus 11. This is so nice, super amazing. It just goes straight in from one piece to the other. I mean, phenomenal. We don't have to make any sort of placeholders whatsoever. I wish all problems were that basic, but alas, here we are. We are going to divide by this x minus 3, and then we need to make sure that we know how many times I need to multiply x by to get to this negative x to the fourth. Obviously, I'm going to make it negative, and I need 3 more x's to get x to the fourth. So then I'm going to go ahead and I'm going to multiply it by this entire term. So I'm going to end up with negative x to the fourth plus 3x to the third. I'm going to take this whole thing and I'm going to subtract it. Well, minus minus gives me positive, so 1 negative, 1 positive, that cancels out. And then 2 minus 3 is negative 1, so here I am again. I'm going to bring down this second term and call it good. So I'm going to change my colors just so that I can see that break between each of the pieces. So how many times does x minus 3 or x go into negative x to the third? Negative times, right? Negative x squared. Because if I do x squared times x, I'm going to end up with x to the third. So I'm going to have negative x to the third plus, because negative times negative is positive, 3x squared. And then again, I'm going to go ahead and subtract this whole thing. Well, negative negative again becomes positive. These guys will cancel. Negative x squared minus 3x squared is going to give me negative 4x squared. I'm going to bring down this positive x. And then I'm going to change my color again so that I can continue with my problem. Well, how many times does x minus 3 go into this, or just x goes into negative 4x squared. It'll be negative 4x, because x times x is x squared. Negative 4 times 1 is negative 4. And then I'm going to take this negative 4x and multiply it by the entire x minus 3. Negative 4x squared, right? And then negative 4x times x, negative 4x squared. Negative 4x times negative 3 is going to be positive 12x. I'm going to subtract this whole thing. These guys will cancel. X minus 12x is going to be negative 11x. Oh boy. And then I'm going to bring down this negative 11. That's kind of like awkwardly not. Okay, whatever. I'm over it. And then here we are again with these two terms. Now, x can still go into negative 11x. So our job is to just multiply it by negative 11. So we're going to do that. And then we're going to say, okay, negative 11 times x is negative 11x. Negative 11 times negative 3 is positive 33. And then I'm going to subtract this whole bottom thing. This cancels out. Negative 11 minus 33 is negative 44. Again, there is nothing that I can do in order to take x and multiply it by something to get it negative 44. So we're at a position where we now have this remainder. In order to show my remainder, I'm going to do plus, negative 44 over this x minus 3. Final answer. Again, these are pretty, whoa, that is, okay, well, you got the idea. That was like a little whoop type of box. That's not a normal box. That's okay. Everything's fine. Again, these are not answers that you are going to get as you move further into chapter 4. I think in the very beginning of chapter 4, these are very typical answers, where you're looking for, is this an actual factor of the polynomial or not? So then we will know that actually x minus 3 is not a factor of this entire long polynomial. So here we are. The other thing that I did want to mention, as I was moving through this, I kind of wanted to be like, hey, it's fine. I don't really need the parentheses. And then I thought in my mind, no, Anna, you do, because you just forgot that minus. And it kind of looked a little seamless in the video, I'm sure, but I guarantee you it was in my mind. I thought it. And if I thought it, and if I do math that like so much more than you do, I'm pretty sure you may also think the same thing. You may get confident. And I just, as much as I want you to feel confident, I also want you to understand that your errors are not good. Like, we don't want to make these errors on tests. Definitely making these errors when you're alone, or when you're with a tutor, or when you're in, doing homework or getting help. Those are fine. But when you're on your test, you really don't want to make those errors. So please, 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 definitely go ahead and continue to put those parentheses so that it'll just bring your brain's attention to, hey, this is not just regular adding, we're subtracting this whole thing. Okay. Thank you for giving me some TED Talk. And here we are. Last problem of the video. You've made it this far. I really appreciate this. I hope that this was super helpful, and I'm sure that we will be able to see each other again in the later video when we are talking about this, the rest of chapter 4. Okay, so like I said before, we definitely want placeholders. Now, do we want placeholders after x squared? No, we don't. We just want placeholders in between all of the numbers that we have if we need more of them. So in this particular case, I know I want x to the 4th, x to the 3rd, which is going to be 0, x to the 3rd, and x to the 2nd. Okay. So I know my coefficient for x to the 4th is 1. So I'm going to put in 1, 0, and 5. Those are the numbers that I'm dividing by. I'm dividing these numbers by, actually, this is kind of like that parentheses that we saw earlier, right? By -4. So if you remember correctly, In the last time we did synthetic division, we didn't put x plus 4 just like we put like directly from here to here. We actually set this equal to 0 and then went in with -4. So again, for synthetic division, we're bringing down the 1. 1 times -4 is -4. 0 minus 4 is -4. -4 times -4 is positive 16. 16 times 5 is 21. So again, if I were to go in and divide these two, I would end up with an answer that has x to the third, because fourth is my highest exponent. I've now just taken away this one of these x's. So now I'm at 1x to the third minus 4x squared plus 21 over x plus 4. Final answer. Again, I'm pretty sure I know which method you prefer, but if if you think I'm not correct in saying that synthetic division is the preferred method, please let me know. And I would love to have a chat with you on why you think long division is way more fun and way more easier and just way more than synthetic division. I will see you guys in the next video when we talk about factoring polynomials completely and graphing them. Bye.